Hi dear audience, this video I am uploading today, and this is an introduction to it. Is actually doesn't have nothing concerning the integration via proof video. It's simply a comment from me to all my audience, because my channel is not a specialized channel. Truly 60% of my videos are comments on boxing matches, but my channel contains thermodynamics, mechanics, kinetics, physics. If you're not interested, anyone who would watch this video in boxing might not be interested in boxing. He could turn to a video concerning thermodynamics or math. And conversely, if he's interested in boxing and not interested in the other branch, surely he has friends, or one or two at least friends or acquaintances that are interested in the other branch. So don't deprive them from being informed about it. It could be useful to them. It might clarify any point that is vague or not clear to them. It would be nice of you to tell your relatives about, or acquaintances, friends, about the other branches that you might find in my channel and you are not interested in. Thank you, dear audience. Bye. To my video if you are interested in math, integration proof. Bye.
Let us solve together these two integrations. The first integration, I1, the integral of e to the power x cosine nx dx. To solve it, we use the rule of by parts. Integral u dv equals u v minus integral v du. For simplicity, of course, it would be very difficult to solve if we assume the opposite. So the best assumption is to assume that e to the power x dx equals dv and cosine nx equals u. Why? Because the differential or the integral of e to the power x is itself the second integral, the integral of e to the power x sine nx dx. Here also we'll consider e to the power x dx equals dv and sine nx equals u. Now here is our rule enframed. The first integral would be e to the power x cosine nx. E to the power x is v and cosine nx is u, minus the integral of v du, the differential of cosine nx, which is minus sine nx times the differential of nx, which is n, all dx. But as you see here, this expression integral e to the power x minus and minus becomes plus. Sine nx times n dx is equal to I2 multiplied by n. So we can write I1 equals e to the power x cosine nx plus n times I2 because of this n. Now let us set out to solve the integration I2. So we have here I2 equals e to the power x sine nx, because this is the integral of v, the dv, which is v. The integral of e to the power x is itself, minus the integral of, that's integral is actually v du, the integral of v differentiating sine nx, we get cosine nx, and then differentiating nx we get n, all dx. And if you notice here, this expression is equal to I1, the expression of the integral of I1, but multiplied by n, the same as the case of the integration of I1, which is equal to this expression plus n I2. So here we have I2 e to the power x sine nx minus n times I1, because this expression is the same as the expression for I1 but multiplied with n. That's the expression for I2. Thus, let's call this equation 2. Now substituting for I1 here, let's leave I2 for now. So I1 is equals e to the power x cosine nx plus n times I2. Substitute for I2 here, which is n times e to the power x sine nx minus n into the integral of e. I have taken the n out of the integration being constant, minus n into the integral of e to the power x cosine nx dx. The n outside the x multiplied by all this expression, which is equal to I2 here. I put n and substituted for all this expression here. And arranging and reducing the above expression, we have e to the power x cosine nx plus n, multiplying the n into these two terms, n times e to the power x sine nx minus n square, n time multiplied by the n, into I1, because this is equal to the expression of I1. And transferring the minus n square I1 to the left hand side, we have I1 plus n square I1 equals e to the power x plus n into e to the power x sine nx. And taking I1 common factor for the left hand side, we have I1 into 1 plus n square equals the right hand side. So here I1 equals the right hand side divided by 1 over n square. And similarly, in a similar way for the proof of I1, we can obtain I2 to be this expression e to the power x sine nx minus open bracket n into e to the power x cosine nx over 1 plus n square. So that's all. So these are the two expressions or formulas of the integration of integrations. Integral of e to the power x cosine nx dx and e to the power x sine nx dx. Dear audience, I hope you will find this proof interesting and perhaps valuable. Thank you and goodbye.